Assalamualaikum and good day. Today I am going to present my project in data communication and networking project. First and foremost, I would like to introduce myself. My name is Aishah and my team members Aniq, Amirul and Hasif. So the project scenario is given to us as a figure of a logical network flow. So the network flow from a home network to UTM facilities. So the scenario is that a UTM lecturer is trying to access the ULEN system located in UTM's network facilities. He uses his modem to connect to the public network in order to connect to UTM's network facilities. And also, from UTM network, data is then forwarded to IT center where the UTM ULEN system server is located. So the given information is this. UTM's private addressing scheme is a class C private. And then subnetting concept is used to segregate the network address. IT center is assigned as the 11th available subnet and ULEN system server is assigned to 3rd available address. So the task is that we need to use all the information given to identify the address of the ULEN system server. So the first OSI layer model is the application model. So basically, the UTM lecturer creates data using an application to be uploaded into the ULEN system server system. The data can be anything such as lecture notes and assignments. The lecturer may use Microsoft Word or PDF application to create this data. Moving on to the presentation layer, the data sent by end user is decrypted, decompressed and converted from bits to characters and numbers in the ULEN system server. Next is the session layer, where the session layer manages, establishes, and also synchronizes the data sent by the end user. So, the data circuit terminating equipment, DCE, is a modem, which is used to terminate sessions. Only then will the data be passed on to the next layer, which is the transport layer. So, this layer is where it decides to use either TCP or UDP, and once received by the transport layer, which most common would be the use of TCP to ensure proper message delivery. This layer encapsulates the data with the source and also its destination ports. Moving on to the network layer will receive the transport layer's PDU, encapsulate it with the source and also the destination IP addresses, then send the entire packet to the appropriate recipient, which is the UTM IT center. Next is the data link layer. The data link layer is responsible for transmitting frames from one node to another. This layer combines the raw data into bytes and then bytes into frames and then transmits the frames to ULEN system server. Conclusively, at the ULEN system server, this layer receives the signal, decodes it into frames and delivers it to the hardware. Next is the physical layer, where we need to make sure that the ends of the UTM lecturer and the ends of ULEN system server should be in synchronization to ensure that the data sent by the end user is assembled in the correct order. Moving on to the subnetting calculation, where the first byte of the given network prefix is 192, which we receive this number, making it a class C address. So the given network prefix is 192.168.0.0/16. So the subnet mask is as below. We obtain the subnet mask is 16. And then there are 30 subnets for 30 different departments. So we need to calculate the quantity of the subnet using this formula, where we obtain the borrowed bits. Where we can find the borrowed bits, where the borrowed bits is 5. And from the borrowed bits, we need to find the number of hosts for each subnet. Using this formula, we obtain the host number is 2046. Therefore, each subnet has 2046 hosts. Moving on, there are 30 subnets. Thus, it is time consuming to write all the subnet ranges, so we wrote down until IT center subnet. In this presentation, I attached the 10th subnet of IT center, which is as below. So the subnet 10 is the 11th subnet. This is where IT center is being assigned. So the result that we obtain is that 192.168.803 is the third available address in IT center subnet. Therefore, this address is where the uLearn system server is being assigned. So the moving on to the TCP/IP setting manual. For this setting manual we use Windows 10 OS because it is the common OS in mostly all devices. So step 1, open settings and go to network and internet as shown here. Step 2 is go to Wi-Fi or Ethernet, then click the name of the Wi-Fi or Ethernet. Next, step 3 is to scroll down until IP settings, then click edit. Then change the default DHCP to manual, then key in all the required information as below. So the findings and experience while creating this project is that we faced many challenges and also obstacles in completing this project, such as we obtained a wrong calculation and we obtained different opinions from each members that we need to resolve it and obtain one final decision. So based on this experience, our teamwork is built, and for me, I think it is a good experience. Thank you.